you everything. The entire history of the world. What if we could do it in just 2 hours? We're going to tell the whole story. From the Big Bang to the present day. How the planet prepared for the rise of man. How the Stone Age led to the steam engine. How the first seed sprouted into cities and civilizations. Everything is connected, and the path leads to you. It took history 13.7 billion years to unfold. We'll show you everything you need to know in the next 2 hours. This is our infant universe. Everything that will ever exist, everything that will ever happen, begins here, within this tiny bundle of energy, smaller than an atom. At this moment, history as we know it is about to mysteriously begin. For reasons we may never know, our universe suddenly erupts.
In a millionth of 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 a second, it went from a size smaller than an atom to bigger than a galaxy. Whoosh.
What you're seeing is energy. It's a crucial key to understanding everything that will unfold in the next 2 hours. Within a fraction of a second, the Big Bang creates all the energy that will ever exist. All the energy that will power the stars, that will fuel everything that will ever live. All the energy that you will ever consume dates back to the beginning of time.
When you put gas into your car, you're tapping energy that was created during the Big Bang. You're tapping the energy of the universe itself.
After only a few minutes of this 2-hour journey, 380,000 years have already passed. The building blocks of the universe are about to be born. The first atoms. This is hydrogen. The universe will use it to make everything in the world around us.
Hydrogen is like a baseball team. You say, what player do I want to start my team with? Well, if I want to start a universe, I want to start it with hydrogen. Because from that, with a lot of heat and a lot of pressure, you can build more kinds of atoms.
The first atoms blast through the early universe. And luckily for us, they don't spread out evenly. Because in those tiny pockets that have more atoms, gravity, the great sculptor of the early universe, begins to work its magic. The first galaxies are beginning to form, revealing a timeless secret of the universe. Throughout history, whenever more matter and energy can be drawn together in one place, more complex things can emerge.
We have all of these urban centers around the planet where so much creativity, so much art, so much science, so much culture came about because of all these opportunities for things to interact with each other.
Really, in a sense, where there is stuff, new stuff can develop, and where there isn't anything, nothing much can develop.
300 million years after the Big Bang, inside galaxies that are forming, gravity continues to squeeze together clouds of gas and dust, causing pressure and heat to rise violently. When the temperature reaches 18 million degrees Fahrenheit, hydrogen atoms slam together, creating a new element, helium, and radiating bursts of energy. The first stars are born.
Suddenly, there were these new beacons of light shining forth, pouring energy into the universe. Let there be light.
But something is missing from this early universe. There are billions of stars, but not a single planet. To form planets and eventually people, the universe needs to work with more than just hydrogen and helium.
The complicated elements, the heavier things that we build stuff out of, for example, iron or life built out of carbon and things like that, they're actually manufactured in stars.
We may see stars like our sun as sources of heat and light, but deep inside, something else is taking place. Stars are element factories. They fuse hydrogen into helium, helium into lithium. They forge 25 of the most common elements we need to live, including carbon, oxygen, nitrogen, and iron. So, more than 12 billion years ago, stars are already creating the element that will spur the Iron Age, allow for the building of cities and the creation of some of mankind's most famous monuments. But examining the Statue of Liberty reveals the next challenge for the early universe. While the statue's frame is iron, its skin requires an element too heavy to be made in the stars. For the statue to have material for her skin, for there to be gold for wedding rings, for uranium for nuclear reactors, some elements have to be created another way. Stars don't have enough energy to do the job, so if the element factory isn't powerful enough, how about blowing up the factory?
Just a few million years after the first stars formed, some of them exploded. Wham!
These explosions, known as supernovas, are the biggest blasts in the universe since the Big Bang, providing the extra boost of energy needed to fuse heavier elements. In the fiery blast of their own destruction, stars create uranium, gold, and all the rest of the elements that will fill our world, including copper.
The periodic table of the elements is really sort of a library of matter in the universe. Those are your building blocks. Everything is coming out of that particular chemistry set. Supernovas are absolutely necessary for us to be here. You know, we have iron in our blood. We have little bits of old supernova, therefore, just floating around through us. We are all stardust.
Copper and tin, Bronze Age. Without supernovas, there's no Bronze Age. Go to any supermarket and buy a multivitamin. And go and look in the ingredients. You'll find copper, you'll find zinc, you'll find selenium, you'll find all sorts of elements that can only be made in a supernova.
The elements made by stars will become the seeds of life on Earth and the drivers of human history. But the journey has just begun. Before there can be life, the universe has to build a suitable home. To build a house, you have to assemble all the materials in one place.
And now when planets form, it's the same thing. It's the materials that you have at hand that's going to dictate the kind of house that your planet's going to be.
To get enough of the right materials in the right place at the right time takes millions and millions of years. In fact, over the next 8 billion years, more than half of history as we know it, stars continue their work. They explode and are reborn. Each generation with heavier elements than the last. Until 4.6 billion years ago. Finally, there are enough materials for the next step on the path that will ultimately lead to human life. A new star is born. This is our sun. It's so massive that it's gathered up 99.9% of the gas and dust in the solar system. But there's still just enough left behind for gravity to build some other things, like planets. The third one from our sun will be Earth. By the time Earth emerges just over 4.5 billion years ago, 2/3 of the history of the universe has already passed. The first sunrises sweep across a foreboding planet. A world spinning so rapidly that a day only lasts 6 hours.
When you go back to the early Earth, right after the planet formed, you really have to think of the Earth as another planet. The sun would have looked out over a hellacious scene of just molten lava. In places, you would see rafts of black volcanic rock.
Within the liquefied rock, the elements are all jumbled up. Something has to bring order to this chaos. And once again, that something is gravity. Lighter material drifts towards the surface and forms a solid crust, while heavier material sinks down, forming a molten iron-nickel core. This churning liquid metal creates a magnetic field that reaches out into space. Like a force field, it will protect our future home from the sun's deadly charged particles. Soon, this magnetic field will allow for life to grow, and later, guide the explorers who will connect two halves of the world. But for all this to unfold, the Earth will need a critical partner. Four and a half billion years ago, an object the size of Mars smashes into the planet at 25,000 miles per hour. The Earth swallows up much of the impactor. But a spray of molten debris is whipped off into space. Within as little as a year, gravity gathers this debris into a secondary sphere in orbit around the Earth. It's been there ever since.
The formation of the moon was an incredibly important event in Earth's history.
And in fact, its creation over 4 billion years ago is really important to the Earth's climate today.
The moon keeps the Earth steady. Its gravitational pull prevents the planet from wobbling, saving us from wild climatic swings. And the collision that formed the moon leaves the Earth tilted on its axis, giving the planet a key ingredient for life: seasons.
Having seasons is very, very important for the evolution of life on the Earth. And having some stability in the tilt of those axes, that's very, very important also for maintaining life on the Earth.
The moon's gravity also begins to slow the Earth's rotation, and this will eventually lengthen our days from 6 hours to 24. 4.4 billion years ago. It's too hot on Earth for liquid water to exist, but there's water vapor, steam, in the atmosphere. The trick is how to get it out of the sky. A little rain must fall onto any world where you hope to have life. For millions of years, as the planet cools, rain pours down, forming puddles, lakes, and eventually our oceans. By 3.8 billion years ago, our planet has a moon and permanent oceans. But it hardly resembles the place we now call home. In order to support human life, the Earth needs an oxygen-rich atmosphere and fertile continents for people to discover and develop. Who will create our modern world? There's a trillion of them crawling on your skin right now. $3.8 billion years ago, beneath the surface of our primeval oceans, a revolution is taking place. 6 simple elements, including hydrogen from the Big Bang, and oxygen, carbon and nitrogen created by stars, have combined to form the key substances that will make up all life, including us. The most spectacular is DNA. Within its spirals hide the secret codes of life. 700,000 years after the planet first formed, life on Earth begins. We stand not on the shoulders of giants, but of tiny organisms, bacteria.
We're very egocentric. We think that we animals run the world, but in fact, we are very late entrants. It was an empire of bacteria long before animals. Animals come along, and we like to think that we wiped out that empire. Well, we would be dead if we wiped out that empire. I have within me an entire zoo of bacteria.
In fact, each one of us has more bacteria living in our bodies than there are people on the planet. For billions of years, microbes like these will have the Earth to themselves. Like our infant universe, the first life is small, simple, and full of possibilities. The secret of how it explodes into all of the incredible forms we see today, including us, goes back to the beginning of time. As we've seen, all the energy that will ever exist was created in the Big Bang. All creatures need to grab a share of this energy in order to survive. The more we harness and the more efficiently we use it, the more complex we can become. Almost all of our share of the Big Bang's energy is beamed to us by the sun. 2.5 billion years ago, some very special bacteria work out how to consume the sun's energy to live. In doing this, they also create the most important waste product in the history of the world: oxygen. Soon, oxygen will remake our world, but first, it has another important job to do. The Earth's ancient seas are full of iron particles, and everyone knows what happens when oxygen meets iron.
Here I'm a little bacterium. I've produced this oxygen molecule, and here's a big piece of iron clump. I rust it.
The rusted iron collects on the sea floor. Billions of years later, these huge deposits will be raised up to become major sources of the world's iron and steel.
It was these iron deposits that later on drove the Industrial Revolution.
In this way, the Brooklyn Bridge and the other early landmarks of the Industrial Age are a direct link to some of the first life forms on Earth. Once there's no more iron left in the sea to rust, these ancient bacteria have another mission to complete. They create so much oxygen that it fills the oceans and escapes into the atmosphere.
And from then on, we have a very different planet from all the other planets in the solar system.
Now, life takes a giant leap. For the first time, some bacteria learn to live on oxygen. Every human breath is a ritual that is 2.5 billion years old.
Life tends to stick with what works, even over the course of billions of years.
Oxygen is a game changer. By taming its power, life has found a better way to energize itself, 20 times more efficient than anything previously used on Earth. What life does with all this new energy will be the story that leads to us. Over the next 2 billion years, life becomes more complex. Skies become blue, and so do the oceans that reflect them. Large solid continents appear. Earth is beginning to look more like the place we know. $550 million years ago, as the planet celebrates its 4 billionth birthday, oxygen levels in the atmosphere have risen from almost nothing to as much as 13%. Take a deep breath, because life on Earth is about to go wild. This is the Cambrian explosion, biology's version of the Big Bang.
Right after you have abundant oxygen, you get size and complexity. And oxygen lets you do that.
It's during this breathtaking time of roughly 30 million years that most of the major animal groups evolve. By 500 million years ago, the first bony fish have evolved in the seas. These fish are our direct ancestors. Although they look nothing like us, they evolved the body parts that will make our own bodies possible, including a spine and a mouth with jaws and teeth.
We owe a great deal to our fish ancestors. In fact, all vertebrates today really represent modifications of the original fish body plan.
For the first 4 billion years of Earth's history, plants and animals have remained in the seas. But all that begins to change. With oxygen comes an ozone layer, protecting us from dangerous radiation. Plants make the move first. Around 400 million years ago, animals are ready to take the leap. Among the first ashore are the amphibians, whose descendants will include us.
The most amazing thing about animal evolution ever, for me personally, is that moment that first amphibian walks out of the primeval ocean onto land and takes a big gulp of air. Kind of like great-great-great-great-great-great-grandpa coming out of the ocean and seeing this fantastic world. And it's like, hey, I can live here. Look at those trees. Look at those bugs. There's food here. I can do this.
Eventually, humans will conquer every imaginable terrain. But before we can do that, our ancestors must first cut their final tie to the water. Reproduction. Like modern frogs, they have jelly-like eggs that would dry out on land. But some amphibians eventually solve the problem. They evolve a new form of egg, with a shell that keeps the moisture in. This allows us to carry the ocean with us onto land, and signals the evolution of amphibians into reptiles.
You could be 300, 400, 500, 1,000 miles away from water and still have the water in that egg in order to birth. That is the key. It cuts that final tie to the ocean. That way we could colonize the rest of the land.
"300 million years ago, life flourishes in massive tropical swamps where planet Earth is cooking up a surprise. As plants die here, they are buried, compacted, and cooked. Energy created in the Big Bang and radiated by the sun to plants on Earth is now locked away underground as coal, a gift to be opened by human beings millions of years in the future. "250 million years ago, an apocalypse unfolds. The biggest spike in volcanic activity since the early days of the planet. The atmosphere is choked with carbon dioxide, and the diversity of animal life spawned in the Cambrian explosion is stopped dead in its tracks. It's the end for more than 70% of all species on Earth, in the worst mass extinction in history, the Permian extinction. Extinction is a recurring theme in the story of planet Earth. 5 times in the last 500 million years, a cataclysm has wiped out the dominant species. It's a reshuffling of the deck that allows new creatures to take hold. New creatures like the dinosaurs. Dinosaurs will reign for the next 160 million years. During that time, the first hardwood forests appear. And after more than 4 billion years, the moon's gravity finally settles Earth into a 24-hour day. At the beginning of the dinosaur era, the continents are clustered together into a single landmass we call Pangaea. But now it starts to break apart. Africa separates from South America. The vast Atlantic Ocean opens up, creating what will become one of the defining barriers of human history, the gulf between the old and new worlds. The undisputed stars of the dinosaur era are animals like Triceratops and T-Rex. But there are some other important creatures scurrying around their feet.
If we were to trace our lineage back far enough, we would come to really small shrew-like mammals surrounded by these titans of reptile life. During that time, mammals, we were living on the fringes. We were maybe stealing dinosaur eggs, maybe just eking out an existence. So the dinosaurs kind of held us back.
The biggest headline of the history of dinosaurs, which is 160 million years, is that we lost. Mammals lost. We couldn't get much bigger than a small cat. For 160 million years, all the medium-sized, medium-big, big, gigantic, and stupendous animals were dinosaurs. For that whole time. They beat us fair and square.
But the deck is about to be reshuffled. "65 million years ago, a 6-mile-wide object, probably an asteroid, slams into the Earth. A dust cloud blocks out the sun. Temperatures plummet. Every creature on land weighing over 50 pounds becomes extinct. The reign of the dinosaurs is over.
The greatest gift that the dinosaurs ever gave us was dying. When they went extinct, it gave the mammals time to rise.
It doesn't take long after the disappearance of the dinosaurs for the first true primates to emerge. Like their later versions, including us, these mammals have evolved forward-facing eyes, allowing for accurate depth perception, and flexible hands with 5 digits.
They have 5 fingers, just like us, which means we can grasp things. If you think about other animals that don't have digits organized the way ours are, their ability to hold things, to manipulate objects, is much more limited.
50 million years ago, our primate ancestors are evolving on a planet that is warming. It's so hot that there are jungles at the poles. As the continents drift, the Americas and Africa have almost fully taken shape. But in northern Africa, modern-day Egypt is submerged beneath an ancient sea. On the floor of that sea live small shelled creatures called nummulites. Their shells, made of calcium and carbon, pile up on the seabed over millions of years, where they will form into limestone. This limestone will be used to build the Great Pyramids. Looking closely at the pyramids today, you can still see evidence that these 4,000-year-old monuments are in fact made of 50-million-year-old seashells. By 10 million years ago, the Earth is changing into a world that most of us would recognize. The Colorado River is carving out the Grand Canyon. Mountain ranges like the Himalayas have risen. They're so tall, they disrupt weather patterns, setting the stage for a colder planet. The Isthmus of Panama emerges to connect North and South America, cleaving the connection between the Atlantic and the Pacific, disrupting ocean currents and tipping the world even further towards an ice age. With our planet getting colder, our primate ancestors remain in the tropics, but something is emerging that threatens to destroy them. 7 million years ago, our primate ancestors lived safely in the trees, but their territory is about to be invaded. This newcomer will have as profound an effect on human history as any other living thing on Earth. It seems almost impossible to believe, but one of the most important factors that will lead to the emergence of us is the emergence of grass.
The grasslands appear almost simultaneously around the world. We get the African savannas. We get the Eurasian steppelands. We get the North American prairies. We get the great grasslands of Argentina, appearing simultaneously around the world.
In eastern Africa, grasslands invade the traditional woodland habitat of our ape ancestors. With fewer trees and greater gaps between them, our ancestors are forced to adapt.
Apes, we've noticed that there's more and more apes in the same tree and less food, increasing incentives for apes to go from one patch of food to a different one separated by grasslands. Now, one way to do it is to run like hell. The other way to do it is to extend one's food sources into the grasslands and seek out the foods that are available there.
And so some apes move down into this stark new habitat. It's a landscape better suited to primates that can walk on 2 legs, keeping their heads up above the tall grasses to watch out for predators. Standing on 2 feet is a revolutionary advance. because it frees up our hands. Hands we will need to shape human history. $2.6 million years ago, early proto-humans, or hominids, walk on Earth whose rocks contain the element silicon. Created in the cores of stars billions of years earlier, silicon is the second most abundant element in the Earth's crust. One of its chemical quirks is the ability to bond with oxygen to form crystals that combine into solid rocks, rocks that can be chipped and shaped without shattering.
Hominids started doing this 2.6 million years ago, breaking cryptocrystalline silicates to make sharp edges, and people use them for millions, literally 2.6 million years.
Simply having a modified stone with a sharp edge on it, now suddenly you have a hammer. You have a crude cutting edge. A simple modified stone means a human can suddenly do 1,000 more things than we could do previously. That little extra bit of technology enabled our ancestors to persist and eventually turn into us.
Silicon launches the first technological revolution, the Stone Age. Millions of years later, it will power our first handheld devices. Another chemical quirk of silicon will once again make it the height of technology. The next leap towards becoming truly human lies in a little-known secret of our world. In the known universe, it seems that Earth may have a rare and special power.
Of all the planets and moons in the solar system, we think that Earth is unique in the ability to sustain fire.
Other planets and moons have lightning and lava. But only on Earth do we have the two critical things needed for fire to burn. A vast fuel supply in the form of plants and trees, and an atmosphere full of oxygen to fan the flames.
If fire wasn't a possibility, you'd have nothing like us running around. Homo sapiens, they made a world with fire.
Our ancestors have fire firmly under control by 800,000 years ago. It's a skill that connects us back to the very beginning. Remember that all energy was created in the Big Bang, and all life is in competition for our share of this energy. Using fire to cook is like having an external stomach to break down foods, releasing more calories, giving us more energy, which in turn allows us to support bigger brains. Fire is also the ultimate gateway technology. We will soon use it to turn clay into pottery, metal into weapons, water into steam power.
If you don't have fire, you can't have the internal combustion engine. No fire, no metal. No fire, no rubber. It's a technology that opens a world of possibilities for creatures that know how to use it.
"200,000 years ago, the modern human has taken shape. The larynx or voice box, which was high up in the throat of our ancestors, descends. More complex sounds are now possible. We begin to speak. For the first time, information can be shared between individuals and across generations. humans have gained a critical advantage over every other creature on Earth.
You can tell my grandfather said that when the elephants didn't show up, we go off and hunted zebras. You know, my aunt told me that her cousin found this water hole on the other side of that river.
And we can all benefit and we can all understand what they mean when they're describing what they found out on that landscape.
Language changes humans from being like standalone computers to being networked computers, where you can share information. You know, one doesn't need to depend on one's own personal experience. One can borrow the personal experience of anyone with whom one can communicate. That's a powerful advantage. No other creature has that.
As a species, humans become exponentially more intelligent. The global game board has been set, and we are now ready to play. 100,000 years ago, man can move. We have agile hands and primitive tools. We can communicate and control fire. We're finally ready to expand out of our African home. On a path millions of years in the making. Shifting continents have linked Africa and Eurasia into the largest contiguous landmass on Earth. Afro-Eurasia. 33 million square miles, more than twice the surface area of our entire moon. For early humans, this means that more than half the land on Earth can be reached on foot.
Human dispersal was a crucial game changer. We are one of the few primates that live on more than one continent simultaneously. So what that means is that we're better insulated from the kinds of things that cause big mammals to become extinct than other primates are. It's extinction insurance. Dispersal is extinction insurance.
But just as the world begins to open itself up to man, the planet turns on us. An ice age begins. Now the planet will test us like never before. By 50,000 years ago, glaciers begin to advance down from the North Pole. At the same